Today we're going to be talking about rectangles. Rectangles are a type of quadrilateral, and they're also a type of parallelogram. So we're going to review the properties of a rectangle. Okay, so first of all, a rectangle is always going to have 4 right angles. Okay, so this is going to be a rectangle. We have to have 4 right angles. All right. Next property, the opposite sides of a rectangle are parallel and congruent. Remember that we mark parallel with the little arrows, and we mark congruency with the tick marks. Same number of arrows means that those lines are parallel. Same number of tick marks means that they are congruent. Okay. Also remember this little double line here means parallel, and the equal sign with the squiggle over it means congruent. So we're using those symbols a bunch. Our next property is that the opposite angles of a rectangle have to be congruent. Now remember that that's going to be true anyway because of the first property where we said that, hey, guess what? All of them are right angles. So that means that they are all congruent. But by definition, because it's a parallelogram, opposite angles have to be congruent. Okay. We also have opposite angles are going to be, not opposite, consecutive angles are going to be supplementary. And remember that consecutive angles are angles that are next to each other. So that would mean, like these two angles, if you add them up, they would equal 180. And fix that. These two angles, if you add them up, they would equal 180. These two angles, if you add them up, would equal 180. And these two angles, if you add them up, would equal 180. And that's what supplementary means, is that the angles will add together to equal 180. Okay. On a rectangle, the diagonals are going to bisect each other. So when we draw our diagonals here, they're going to cut each other exactly in half. Okay, so it's the same as what we learned about all the other parallelograms. And then our new one, and I've written it here in red because this is new. So the diagonals of a rectangle are going to be congruent. Okay? So that means from here to here, so let's give this one a name. That would be diagonal AC would be congruent to diagonal BD. Okay, because if it's a rectangle, the diagonals are congruent. That is new. That was not true of all of our other parallelograms. Okay, so how are we going to be able to prove that our diagonals are congruent? If they give you the coordinates, that they're on a graph, then you would want to do distance formula. Okay, so if you need to check and see if the diagonals are congruent, you might be looking at distance formula. So I'm going to give that to you again. We learned it in the very first chapter, not chapter 0, but the very first chapter. And it is the big long square root. I know all of you really loved this one. I know that you're all really excited to see this one come back. The most commonly made mistake the first time through this was that people would put a negative sign here in between the x2 minus x1 squared and the y2 minus y1 squared. And so please remember that that is a plus sign in the middle. Each individual parentheses has a negative sign or minus sign, but between the two parentheses is going to be a plus sign, and that's going to be really important as you go through and work this. Also remember, this formula is on your green sheet, so you don't have to have it memorized. You just have to know to plug in your x2, x1, y2, and y1. You need to know where those coordinates go in the formula. Other than that, you actually get the formula for tests and quizzes on that green sheet. Okay, what else are we going to need to know for this section? Well, we're going to also need to know that if you have a parallelogram, okay, so we're going to have a couple of ifs here. So if it is a parallelogram, remember a parallelogram is a slanted rectangle shape, and the diagonals are congruent. We just talked about how you could check that. Okay. Then, so this is what we're going to know. So the if is what we have to check. The then is what we're going to know. Then it is a rectangle. So that sounds really easy. It sounds like we really just have to satisfy two conditions and then we can prove that something is a rectangle. Keep in mind that if we're trying to prove two things, we have to prove that it is a parallelogram, and we can use all of that using the information in 6.3, those tests for parallelograms. So if we know, both pairs of opposite sides are congruent, or we know both pairs of opposite sides are parallel, or that the diagonals bisect each other, or we have that whole list. If we know any of those things, the opposite angles are congruent, then we'll know it's a parallelogram. Then the second thing we have to check is, are the diagonals congruent? So not only do they bisect each other like they did for all the other parallelograms, they also have to be congruent. If we can check those two things, then we'd be able to show that a shape is a rectangle. Okay, so that's going to come up in your questions. Okay, so let's look at one example. Okay, so here we have this, and we have some information given to us about this rectangle. The first thing is that they do tell us this quadrilateral WXYZ is a rectangle. Okay, so they're telling us ahead of time it's a rectangle. And they've given us two sides, okay, and since we know that it's a rectangle, some things that we could go ahead and label. We know the opposite sides are going to have to be congruent, so we know these two sides. And we know that the two diagonals are going to have to be congruent also, since they're telling us it is a rectangle. So that means that both of these are going to be the same. So if we can find one, then we have to know the other one. Now, unfortunately, it's not as simple as just looking at the information they gave us, because they tell us XZ is B, so that's great. YW is B. Oh, wait, that's not a number. Can we do better than that? Okay, and so that's always going to be our goal, is can we do better than that? And so on here, one of the things that we're really interested in looking at is we have a triangle. And so you're going to notice, we've mentioned this right at the beginning of quadrilaterals, that you create two congruent triangles whenever you draw those diagonals, but we haven't used the triangles a whole bunch. So now we're going to do that. So we have to remember that our angle down here is a right angle. That makes this a right triangle that I've outlined in yellow. And so we can use our Pythagorean theorem to find the third side here. Okay, so I'm going to go over to another page and we'll come back. I just need some more room to write. And so remember, our Pythagorean theorem is a squared plus b squared equals c squared. And if we look at our picture, this missing side that we're trying to find out is going to be c, because it's the hypotenuse. It's across from the right angle as far as the triangle is concerned. And so it has to be c. The 3 and the 4, they can be a and b. It doesn't matter which one goes where. So we're going to have 3 squared and we're going to have 4 squared equals c squared. And we're trying to solve for c. So you go ahead and square each of those, because at this point this is an algebra problem. Okay. And we get that c squared equals 25. This is the step where most people make their mistakes, so I don't want you to be one of those people. Remember that to get rid of this squared symbol here, we have to take the square root, because squaring and square rooting are opposites. And so when we do that, we find out that c equals 5. So we're going to look at our picture here. So this side is 5. And remember that if xz is 5, that means that yw is also 5. And so that's going to be our final answer, is that yw equals 5. Just so you know, there is a slightly faster way you can do some of these. You might be interested in looking up what are called Pythagorean triples. Okay, so I'm going to write that out here. And Pythagorean triples are going to be sets of 3 numbers, it's the word triples, that if you take the smaller 2 and you square each of them and add them together, you plug them into the Pythagorean theorem in essence, then you would get that third number. Okay, so like 3, 4, 5 is a Pythagorean triple because every time you have that set of 3 numbers, you are always going to get 3, 4, 5. So if they give you the 3 and the 4 and you're solving for the hypotenuse, you will get 5. If they give you the 3 and the 5 and they tell you, the 5 is the hypotenuse, then you'll know the other leg is 4. So it might be helpful for you to look up some of those and make yourself a list. I will tell you that at the very least, you want to remember 2 sets. So that's going to be 3, 4, 5, okay, and 6, 8, 10. And those are going to come up over and over again, and they'll save you a lot of work if you'll just remember them, okay. I hope that you have enjoyed watching. Thank you, and I hope you have an excellent weekend. I will see you on Monday.